Let us now determine whether my geometric model and its subgroups are cyclic. So, let's define what is cyclic first. So, a group G is cyclic if there exists an element G is an element of G such that every element in G can be written as a power or multiple of G. So, for our conditions, cyclic must be abelian and it must have at least one generator. So, let's see if my geometric model is a cyclic group. So, is it abelian? So, first, when we say abelian, it must be commutative for all elements. So, as we analyze the table, this group is not abelian because the table is not symmetric along the diagonal. So, for example, G star H is not equal to H star G because G star H is equal to P and H star G is equal to I. So, it is not commutative. So, we can say that this group is not abelian. So, let's now check if it has a generator. So, here are the list of all the elements that is generated by an element. So, if you notice, there is no element that generates all the elements of the set. Therefore, there is no generator. So, since we fail to satisfy both the conditions under a cyclic, therefore the group is not a cyclic group. So now let's proceed to its subgroup. First is we have the subgroup M sub 1 where the set of N, A, B, C, D, E, F, G is operated by star. So, is this group or is this subgroup abelian? So, this subgroup is abelian because the table is symmetric along the diagonal where for every pair of elements A and B, we have A star B is equal to B star A. So, does it have a generator? So, as we can see that the generators in this subgroup is A, C, E, and G. Therefore, it has a generator. Now, we can conclude that this subgroup is a cyclic subgroup because it satisfies all the given conditions. So next is we have the subgroup M sub 2 where the set of N, B, D, F is operated by star. So, is this subgroup abelian? Yes, this subgroup is abelian because the table is symmetric along the diagonal where for every pair of elements A and B, we have A star B is equal to B star A. So, does it have a generator? So, we can see that the generators in this group are B and F. Therefore, it has a generator. So, now, we can conclude that this subgroup is a cyclic subgroup because it satisfies all of the given conditions. Next, let's see if these subgroups are cyclic subgroups. So we have the subgroup M sub 3, M sub 4, M sub 5, M sub 6, M sub 7, M sub 8, M sub 9, M sub 10, and M sub 11. So these subgroups are abelian because each table is symmetric along the diagonal where for every pair of elements A and B, we have A star B is equal to B star A. And also, we can see that there is at least one generator for each subgroup. So we can conclude that each subgroup is a cyclic subgroup because it satisfies all the given conditions. Let us now relate the order of the group and the order of its subgroup. So first, group M is order 16. Subgroup M sub 1 is order 8. Subgroup M sub 2 is order 4. And then subgroup M sub 3, M sub 4, M sub 5, M sub 6, M sub 7, M sub 8, M sub 9, M sub 10, and M sub 11. These are all order 2. And lastly, for our trivial subgroup, which is M sub 12, this is order 1.